In this video, we are going to be focusing on problems involving the assessment of spectrophotometric method for determining the titanium content for alloys. Let's assume we are given this kind of problem which says in order to evaluate the spectrophotometric method for the determination of titanium, the method was applied to method sample containing different certified amount of titanium. The result of the titanium in percentage is shown below. Here we have the sample which is 1, 2, 3, and here we have the numbers of certified value which is 3 also, mean, standard deviation. The first sample, which is the number 1, we have the certified value to be 0.496, the mean 0.482, and standard deviation is 0.0257. And what we are asked to find here at the end, it says for each alloy, its replicate determination were made. And we are asked to determine for each whether the mean value differs significantly from the certified value. Alright, how can we solve this problem? In order to determine whether the mean value differs significantly from the certified value, we can perform the t-test. When we say t-test is given by small letter t, which is equal to x bar minus mu divided by s divided by square root of n. In this case, the x bar simply stands for mean, and the mu is the population mean, which is the certified value. And here the s we are given at the standard deviation, and n is the number of observation. And the number of observation here is the number of our replicate. Numbers of our replicate here we are given 8. That is why they say for each alloy, 8 replicate determination were made. Therefore, the number n is simply going to be 8 for everything which you have in the table. So, and next thing we need to do is to determine the degree of freedom. The degree of freedom is given by df, which is simply going to be n minus 1. Our degree of freedom is simply going to be x minus 1. Alright, we said our formula is given by t, which is equal to mean minus mu, and we said the mu is the certified value divided by the standard deviation divided by the square root of replication, which is n. Next thing we need to do is to compare the calculated t value with the critical t value from the t distribution table for given degree of freedom and the desired confidence level, which is usually 95%. And last thing you need to do is this: if the calculated t value is greater than the critical value, then the mean value differs significantly from the certified value. Otherwise, there is no significant differences. Let's start solving this problem. Here we have first alloy, second alloy, and third alloy. We are going to calculate each and every t-test for the first, second, and third, samples which we have here. Let's start with the first one. Let's say alloy 1. In this case, if you notice here, we have certified value, and certified value we are given 0.496. That is our mu, which is going to be 0.496. And we are given x bar, which is our mean. If we check our mean is 0.482. And the standard deviation is given to be 0.0257. And we are given n, which is the numbers of replication, is given to be 8. In this case, we are going to substitute everything into this formula. Therefore, we have t, which is equal to our mean, which is 0.482, minus mu, and our mu here is 0.496, divided by our standard deviation. Standard deviation, given the standard deviation, which is s, which is this, is going to be 0.0257 0.8257. We are going to divide everything here by the square root of 8. Alright, our numerator here, if you subtract 0.496 from 0.482, this is simply going to be negative. Therefore, we're going to have negative 0.0104. Sorry, negative 0.014 divided by, let's repeat this value, which is 0.0257. You are going to divide that. What is the square root of 8? The square root of 8 is simply going to be 2.828. Remember, here we have division sign. Alright, here we're going to have negative 0.014. If you divide 0.0257 by 2.828, this is simply going to be 0.0091. If you divide the numerator by the denominator, your t value here is simply going to be negative 1.54. And for the first alloy, this is for this problem. What about the second alloy? We're still going to be using the same table, but here this is second alloy. Okay, our mean for the second alloy using the table is going to be 1.009. On our mu, which we said is satisfied value, which is going to be 0.995. What about our standard deviation? Standard deviation is simply going to be 0.0248. The next thing we have is n, which is the replicate, which we said is simply going to be 8. So, next thing we need to do is to insert our, formula. Substitute everything into our formula. The formula is given by t, which is mean minus mu divided by the standard deviation divided by the square root of n. Our t is going to be, what is the value of mean? Our mean is 1.009 minus 0.995. We are going to divide everything by 0.0248 divided by the square root of 8. And we said square root of 8 is simply going to be 2.828. Therefore, we're going to have 0.0248 divided by 2.828. If you subtract the numerator, you're simply going to be left with 0.014. What about the denominator? If you divide the denominator, you're going to be left with 0.0088. At this point, your t value is simply going to be 1.59. Let's check something at the first one, which I forgot to mention. In this case, the first one, which is the first alloy, our calculated value, let's say our calculated value is simply negative 1.54. Our degree of freedom is going to be 8 minus 1, which is simply going to be 7. So so at this point, we can say the critical t value from the t distribution table is simply going to be 7. So our alpha here is going to be 0.05, which is two-tailed test, which is approximately, or let me put it equals to insert, which is approximately plus or minus 2.364. At this point, since our negative 1.54 is less than 2.364, right? The mean value of alloy 1 does not differ significantly from the certified value. When we come to the second one, which our calculated value here is given to be 1.59. And we said our degree of freedom is simply going to be 8, which is n minus 1, which is 8 minus 1, which is simply going to be 7. The critical t value from the distribution table is simply going to be 7. And our alpha here is simply going to be 0.05. So and we said it's approximately plus or minus 2.364. In this case, we can finally conclude and say, since here we have what 1.59, since our 1.59 is less than 2.364, we can say the mean value for alloy 2 does not differ significantly from the certified value. The only thing we are left at this point is the last one, which is alloy 3. Pay attention to this. In alloy 3, we have the mean, which is going to be 1.505. And we have the mu, which is the certified value. If you check your table, you see it there, which is what 1.493. And we have the standard deviation for the third one, alloy 3, which is 0.0287. And we have the n, which is the replicate, which is 8. Remember, the reason why I keep on writing 8, we said, they all have that 8 numbers of replicate. That is from the equation, right? So in this case, we can bring back our formula and insert everything. We said our formula is simply going to be T, which is going to be T bar, which is the mean minus mu divided by S divided by the square root of n. At this point, we can insert our values into the equation. Our T is simply going to be 1.504 minus 1.493 divided by standard deviation, which is 0.0287 divided by the square root of 8. And we said square root of 8 is simply going to be 2.828. At this point, if we deduct 1.493 from 1.505, this is simply going to be, our T is going to be 0.012 divided by the denominator. Denominator here, the square root of, let's start with the left hand side, which is going to be 0.0287 divided by 2.828. Our T value here, if we divide this by this, we are going to repeat our numerator. Our numerator is simply going to be 0.012 divided by 0.02087 divided by 2.828. This is simply going to be 0.0102. Our T value here is simply going to be 1.18. If this is what we get at the last, that is the calculated value. The calculated value for the alloy 3 is simply 1.18. So, and the degree of freedom, which is dF, is simply going to be 8 minus 1. Degree of freedom is going to be n minus 1, which is equivalent to 8 minus 1. The critical T value from the distribution table is simply going to be 7. And we have our alpha here, which is going to be 0.05, that is two-tailed test, right? Which is approximately plus or minus 2.364. That is if you check on the table. Since this is what we are given as 1.18, which is less than this, we can finally conclude and say the mean value for the alloy 3 does not differ significantly from the certified value. So at the end, what I'm trying to explain about all these 3 alloys, the mean value do not differ significantly for the certified value at 95% of the confidence level. Because the first one we are given here, in the first problem, we are given negative 1.54, which is less than 2.364. The second one we are given is also 1.59, which is also less than 2.364. And the third one here we are given is, it's 1.18, which is also 1.18, which is also less than 2.364. So this is it for this problem. I hope you find this video helpful. Feel free to like, share, and subscribe. In this video,